In this video, we'll be solving a question from quadratic equations. If k minus 1 of x square plus k square minus 3k plus 2 of x plus k cube minus 1 equal to 0 for every x element of real numbers, which means x or whatever the value of x you are putting, those are real numbers, which is indirectly telling that the quadratic equation has real roots, whether it is distinguished or same root, they are real, not imaginary root. The number of values of k can take are, how many values k can take? Now the thing is, since the quadratic equation has real root, we know that b square minus 4ac will be greater than or equal to 0. It can be greater than or equal to 0. Now what is the value of b? B is the quotient of x, that is k square minus 3k plus 2 the whole square minus 4 into a value is k minus 1 and c value is k cube minus 1 is greater than or equal to 0. Now we will be solving this inequality. Now this thing you can factorize it. If you are familiar with x plus a into x plus b identity, which is equal to x square plus a plus b of x plus ab. Now you know that the product of minus 1 and minus 2 is 2 and the sum of minus 1 and minus 2 is minus 3. If you are familiar with that one, you can directly write it as k minus 1 into k minus 2, or you should go with splitting the middle term. So this is how we can factorize this thing, the whole square minus 4 into k minus 1 into k cube minus 1 greater than or equal to 0. In next step, what we will be doing, we will be giving this 2 individually. This will be k minus 1 the whole square plus k minus 2 the whole square minus 4 into k minus 1. Here we will be applying a cube minus b cube identity. A cube minus b cube identity is a minus b into a square plus ab plus b square greater than or equal to 0. Here you can take a k minus 1 square common. Here you can take k minus 1 the whole square common. So when you take k minus 1 the whole square common, what will be left? K minus 2 the whole square will be left minus 4 into k square plus k plus 1 greater than or equal to 0. Now k minus 1 the whole square into k minus 2 the whole square will be k square minus 4k plus 4 minus of minus 4k square minus 4k minus 4. We just distributed with this negative 4, which will be greater than or equal to 0. Here k minus 1 the whole square, this will be k square and minus 4k square will become minus 3k square and minus 4k and minus 4k will become minus 8k and minus 4 and plus 4 both will be cancelling, which will be greater than or equal to 0. Now we will be making the quotient of k as k square as positive, or you can do one thing, we can take a negative common. So this will negative k common. So when you take a negative k common, this will become k plus 8 into k minus 1 the whole square greater than or equal to 0. Now I will be making all the quotients of k as positive, so that I will be multiplying with a negative. Therefore our inequality will be reversed, less than or equal to 0. That means if 1 is less than 2, if you multiply with a negative value or divide with a negative value, suppose you are multiplying with a negative value, let it be minus 10. So minus 10 and minus 20, the inequality always reverse, because the lower magnitude or negative value will be the bigger one. In that perspective, whenever you multiply or divide with a negative value, your inequality should be reversed. Here we can mark the roots of this equation. Since it is k means k minus 0. So root of this factor will be equal to 0. And if you equate, 1 minute, there is a 3 or the quotient, there is a 3 also for the quotient of k. There will be 3. Now another root will be, if you take the root of this factor, it will be minus 8 by 3, and for this one it is equal to 1. Now the thing is, since the inequality is greater than or equal to 0, equal to sign is there, so root of this can be a solution, and this point, root of this is included, and these points will give you 0 equal to 0. It satisfies, these points will satisfy. Now we need to find out the interval. Since all the quotient of k is positive, you can directly proceed with the adding a plus. Now the thing is, k minus 1 the whole square, since it is a positive even power, it won't affect the sign. Or you can imagine one more time, k minus 1 is already there, one time sign has changed, again a k minus 1 is there, two times sign has changed. So positive will become negative and negative again become positive. And here this 0, the factor which containing root will appear only one time. So sign will change once. Again, here this factor is also present how many times? It only present one time. So sign will again change once. You can imagine that if there is power is even times, whether it is 2 or 4 or whatever it is, it won't change the sign, because sign change will happen even times. Suppose it is 4, plus will become minus, then it will become plus. Similarly, it will happen twice. If it is 3, suppose the power is 3, plus will become negative, negative will become positive, then it will become negative. That's how odd power works. Now we need to take the region which is less than 0, right? That means we need the negative sign. Since it is equal to 0, this point is also taken. That means our value will be from closed minus 8 by 3 to closed 0. That is this interval including the 0, and this 1 will be there, union set 1. Now, before proceeding to this, we need to check one more thing. Suppose k equal to 1. If k equal to 1 means this will become 1. So the quotient of x square will become 0. So do you get a quadratic equation? No, therefore k can't be equal to 1. That means whatever the quotient associated with the k, that shouldn't be equal to 0. Therefore k shouldn't be equal to my plus 1. That means we can't take this one. Therefore we can conclude that k element of minus 8 by 3 comma 0. Now how many values are there in this interval? In this interval there are infinitely many values are there. Therefore our option is option D.